Last episode, we talked about why pipes fail. Corrosion, pressure, ground movement, environment, and time, and how underground infrastructure slowly weakens over decades until something finally gives way. But that raises another question. What were these pipes actually made of? Because not all pipe was created equal. Every generation believed they had found the best solution for moving water underground. And every new material changed infrastructure forever. Believe it or not, some of the earliest water systems used wood pipe, actual hollowed out logs. And for the time, it worked surprisingly well. Wood was available, easy to shape, and cities desperately needed ways to move water farther than ever before. People today hear wood pipe and assume it was primitive, but some wooden water lines survived underground for decades, and in certain conditions, even longer. In some places, pieces are still being uncovered during excavations today. That's the beginning of underground infrastructure. But as cities grew larger and pressure demands increased, wood eventually reached its limits. That's when cast iron changed everything. Cast iron became one of the most important infrastructure materials in history. For its time, it was revolutionary, strong, durable, and capable of handling growing city demands far better than wood ever could. Cities across America rapidly expanded their water systems using cast iron mains. And honestly, many of those pipes are still in service today after more than 100 years underground. That kind of durability is incredible. But cast iron had weaknesses too. It was brittle. Over time, corrosion could thin the walls, ground movement could stress the pipe, and pressure fluctuations could contribute to cracking and failures. And just like today, installation quality mattered too. Still, for its era, cast iron transformed underground infrastructure. As engineering evolved, the industry searched for something stronger and more flexible. That led to ductile iron. Ductile iron solved one of cast iron's biggest problems: brittleness. Instead of cracking as easily under stress, ductile iron could flex slightly and better handle movement underground. It combined strength, durability, and improved resilience. And today, ductile iron is still one of the most widely used water main materials in the industry, especially when properly protected and maintained. These systems can perform extremely well underground. But even ductile iron isn't immune to corrosion or aging forever. No material is perfect forever. Then came materials that, at the time, looked like major breakthroughs. One of those was asbestos cement pipe. Now today, people hear the word asbestos and immediately think danger. But when asbestos cement pipe was introduced, it was considered lightweight, easy to install, and highly resistant to corrosion compared to older metal systems. For many utilities, it looked like the future, and a lot of it was installed across North America. But over time, aging infrastructure concerns, brittleness, and changing health regulations completely changed how the industry viewed it. And now many systems are facing the challenge of replacing that infrastructure decades later. As cities continued growing, larger transmission systems created entirely new demands. That's where large concrete pressure pipe systems entered the picture. Massive pipelines designed to move huge volumes of water across long distances. Strong, large diameter, and critical for major municipal systems. But like every material underground, they brought their own maintenance challenges and long-term risks over time. Then the industry shifted again, this time toward plastics, and that completely changed underground infrastructure. PVC became incredibly popular because it resisted corrosion far better than older metal systems. It was lightweight, cost-effective, easier to install, and smooth inside for efficient water flow. For many utilities, PVC solved problems they had battled for generations. But PVC also introduced different long-term performance considerations depending on installation and environmental conditions underground. Again, every solution created new trade-offs. And now, one of the fastest growing materials in underground infrastructure is HDPE, high-density polyethylene. Flexible, fusion-welded, corrosion-resistant, and capable of handling movement far better than many older rigid systems. In many applications, HDPE allows systems to operate with fewer joints and greater flexibility underground. For modern infrastructure, that's a major advantage. And today, many people in the industry see HDPE as a huge part of the future. But here's what's fascinating about all of this. Every generation truly believed they had finally solved the problem. And honestly, for their time, they usually had. Wood solved transportation. Cast iron solved strength. Ductile iron solved brittleness. PVC solved corrosion. HDPE solved flexibility and joint limitations. But every material eventually reveals new strengths, new weaknesses, and new lessons underground. That's the story of infrastructure. Constant evolution. And beneath our streets right now, all of these generations still exist together. Wood remnants, cast iron, ductile iron, asbestos cement, PVC, HDPE. A timeline of engineering buried beneath our feet. Most people never think about it, but underground, history is still working every single day. And every pipe material tells the story of the era that built it. So next episode, we go back to the very beginning. Before cast iron, before ductile iron, before modern plastics. We're diving into the world of wood pipe. How it worked, why cities trusted it, how long it actually lasted, and why pieces of it are still being discovered underground today. Welcome back to Under Pressure, Underground.